Good afternoon, and thank you for being here. Before I get into the details in the technical report for the power plant options for Central Virginia, I want to take about 15 minutes to discuss the environmental factors that will help shape our decisions. This map represents the demographic geographic regions of Virginia. Central Virginia is in light blue, and it's basically the largest section of Virginia, while Northern Virginia in yellow has the highest population. Richmond is the capital of the Commonwealth, and it's one of its 38 independent cities. The state is divided into 95 counties, of which Chesterfield is the fifth most populated and Henrico the sixth. They wrap around the city of Richmond, creating power demands for 1.3 million residents, as well as local businesses and industry. These metropolitan areas grew originally due to their proximity to the James and Appomattox rivers, but continue to survive and thrive because they're so close to Interstates 64 and 95. This map represents the geologic regions of Virginia. Central Virginia is part of the Piedmont and is the largest geologic region of the state, connecting Washington, D.C. to North Carolina. The James River is the most important watershed in the region, and you can see from this map that much of the eastern portion of the Piedmont is just above sea level because it's shown in dark green. The fall line of the James River runs right through Richmond, and the very first coal mine in North America was in Chesterfield County. The Blue Ridge Mountains form the western boundary of the Piedmont, with the coastal plain on the east, and they both help shape Central Virginia's climate. Weather and climate are not the same thing. Weather is short-term, maybe hourly, daily, even possibly yearly, but it's the atmospheric conditions like temperature, precipitation, humidity, barometric pressure, wind, how cloudy it is, but a very small and specific location. Climate is the average weather in a larger, more general given area over a longer period of time, typically decades. Think of it this way. Any town can have a rainy day. That's weather. But Seattle has over 150 rainy days each year. That's climate. Global warming and climate change aren't the same thing either. Global warming is a significant factor in climate change, but they're not interchangeable terms. So I'm going to go a little bit more in depth. Global warming is the long-term trend of increasing global temperatures, either by natural forcings or by anthropogenic forcings. Don't worry, I'll explain what that is in just a second. But climate change is a change in the total global or regional climate pattern. In particular, a change apparent from like the mid-20th century up till today. It's longer and more widespread droughts, more frequent wildfires, more frequent and stronger storms, and increased ocean acidification are just some of the symptoms of climate change. So global warming is a more specific term. It's very narrowly defined in terms of the degree or intensity of heat present. Maybe this is a good analogy. You can find out if somebody has a fever by taking their temperature, but they may have additional symptoms like being sweaty or having the chills. They could be sore and achy. They can have a headache, maybe really be tired. So there are a lot of ways a fever can present itself and cause other things. So for climate change, the math is really simple. If the incoming energy is greater than the outgoing energy, you get a warmer planet. If the outgoing energy is greater than the incoming, the planet will cool. Incoming energy comes from the sun, outgoing comes from surface radiation. So those forcing factors that I was talking about, this is a pretty easy vocabulary term because it's just any phenomenon that pushes or drives climate change. And they can be either natural or anthropogenic. So on this slide, I organized the boxes roughly in order from the shortest term to the longest and from the greatest impact to the least. According to NASA, about 29% of the solar energy that arrives at the top of the atmosphere is reflected back to space by clouds, atmospheric particles, or bright ground surfaces like sea ice and snow. About 23% of the incoming solar energy is absorbed into the atmosphere by water vapor, dust, ozone, and about 48% passes through the atmosphere and is absorbed by the surface. So add it all up and you get about 71% of the total incoming solar energy being absorbed by the Earth system. Here in Richmond area, we get about 210 sunny days a year and some kind of precipitation on just over 100 days. Pop quiz, is that weather or climate? Just kidding. Let's talk a little bit about albedo. For example, ocean surfaces and rainforests have low albedos, which means that they reflect only a small portion of the sun's energy. Deserts, ice, clouds, however, those have high albedos. They reflect a large portion of the sun's energy. The high albedo of ice actually helps to insulate those polar regions from solar radiation. Greenhouse gases are mainly carbon dioxide, but also water vapor and methane. They're pretty significant too. You can think about how muggy Central Virginia summers are and how many farms with livestock are in this region. Anyway, they're called greenhouse gases because they act just like glass on a greenhouse. They're transparent, yet they're able to keep heat in. Aerosols are the airborne particles that reflect like dust or crystals or absorb like soot. Volcanic eruptions get their own special box because they have gases that are emitted during an eruption that absorb radiation, like carbon dioxide, but the ash is a reflective aerosol that creates a cooling effect. So it kind of can go both ways. And then you have Milankovitch cycles. They take thousands upon thousands of years, and honestly, humans just can't really comprehend or carry a whole lot because the time frame is just so far beyond our puny lifespan. But there are anthropogenic causes of climate change that are very much related to human. Anthro is in philanthropy and anthropology, and genic is in like genesis or generator. So they're the root words for anthropogenic. Anyway, it basically boils down to the fact that humans do things that are throwing the balance of the radiation in, radiation out equation out of whack. We do some things that directly release heat, but that's not the major contributor to global warming that is forcing climate change. Basically, in the span of a century or two, we will burn through most of the hydrocarbon deposits that took millions and millions of years to form. In the process of improving our standard of living, we're also unleashing gigatons of carbon dioxide, extra water vapor, methane, and gases that act like rolled up windows in a car in the middle of a parking lot on a sunny day. The incoming wavelengths of radiation have no trouble passing through to get into the car, but the outgoing wavelengths are a little bit different and they can't get through the glass. There's no escape. So they're trapped inside and more heat accumulates. Remember what I said about the 29% of incoming solar radiation being bounced back to by reflecting ice and snow? Well, we're losing that surface albedo because higher temperatures are melting that cryosphere. Can you see the loop happening? We have less ice, so more heat stays, which melts the ice, which traps more heat, which melts the ice. It makes me think about Joni Mitchell. We are definitely paving paradise to put up a parking lot. Dark surfaces like asphalt absorb heat. Many modern cities and suburbs have really little tree cover to provide any shade. Richmond is actually on an urban heat island list, one of the worst in the country, but I'll get to that in a minute. Even itty-bitty microscopic particulate dark surfaces change the climate. Soot absorbs and smoke reflects. Obviously, there's soot and smoke in nature, but humans rely on combustion and create fires that add tons more to the air than would naturally occur. And so even though smoke technically cools the air, don't forget that whatever is burned up to make the smoke releases gases and carbon into the atmosphere. So more smoke is not a cure for climate change. I'm going to mention ozone too. It's just 3 oxygen atoms bonded together. It doesn't seem like a big deal that when we breathe oxygen to keep us alive, it's only 2 atoms of oxygen. However, loss of stratospheric ozone is a bummer because more UV radiation can penetrate and reach the surface of the Earth, where most living things are. And ground level ozone is basically toxic. Even though it doesn't directly impact global warming, it definitely adversely affects ecosystems, in particular plants. So clearly, the climate and the life forms on Earth have changed over millions and millions of years. There may be some discussion about the snowball Earth period as well as the Anthropocene, but there is enough evidence that scientists overwhelmingly agree that significant events happened then and are happening now, which merit investigation and understanding. So, what was it like in the past here in Central Virginia? Virginia has never been covered by glaciers, but it has been affected by ice ages and the times in between. When the glaciers were advancing from the north, so much water was trapped in frozen form that the sea level dropped 400 feet. Virginia Beach would have been between 40 and 75 miles from the ocean. During the most recent ice age, on average, only 25 inches of rain fell annually. That's for thousands of years. So the climate here was colder and drier. Not quite like tundra. Actually, scientists have collected pollen from sediments that accumulated in various lakes and bogs during these ice ages, and found that in Virginia we had spruce and fir pollen, which are cold climate trees here in Virginia, and as well as pollen of warm species trees like oak and hickory. There's other evidence, such as indications of sand blowouts on the coastal plain, that suggest that Virginia's vegetation was a mixture of forests and prairie. Over time, the climate changed, and as the first Virginians arrived here about 15,000 years ago, they probably found a mixture of pines and prairie, and not the temperate forest that covers Virginia today. The earliest Virginians probably found bison and mastodons and elk and all kinds of other cool things that are no longer around. But in the warmer periods between ice ages, sea level would go up at least 15 feet higher than it is today, meaning Richmond was practically on the coast. At that point in time, the winds carried more moisture, making central Virginia warmer and wetter, and rainfall and temperatures and soil composition definitely defined biomes, and Virginia has transformed into something that we much more recognize more today. However, climate never stops changing. Climate change has gradually impacted the United States for more than the past 100 years, but perhaps it's been too subtle for Americans to notice. As these maps show, the frequency and severity of climate-caused disasters has become so obvious within a single lifetime that multiple generations are experiencing the adverse consequences. As you can see, not all of the top 6 types of catastrophe equally impact each area of the continental U.S., and Virginia is most susceptible to heat waves, winter storms, flooding, and to a lesser extent, tropical cyclones, also known as hurricanes. And we have severe local storms, which must, by definition, happen at a different time of year than between December 21st and March 21st. And for the record, Virginia is not immune to wildfires, as more than 1,000 are reported annually. As you can see, temperatures have been and will continue to rise. The only uncertainty is how much. It may be helpful to remind everyone about the difference between weather and climate. Despite the 60s through the 80s being sort of cool, the overall trend is hotter. That's not just nostalgia. As you can see, temperatures have been and will continue to rise. The only uncertainty is how much. If it were somehow possible to immediately stop all the emissions and go fortify our carbon sinks, like planting forests, for example, or sequestering large amounts of carbon dioxide underground maybe, the temperature would still go up a little bit. That's the blue trend line. If we keep going like we are, with no changes whatsoever, we get the red line scenario. While there is some uncertainty, I can tell you that I'm absolutely positive that I learned climate change in high school and college, and everything that was predicted back then in the late 80s and early 90s is absolutely coming true now. The uncertainty is really not around what will happen, but whether humanity will take the red or the blue. Now, this is a blurry slide, but basically it's showing you that winters are going to become warmer and summers are going to become hotter, and the range for disease vectors like ticks and mosquitoes will expand, and habitat for other plants and animals will decline, and biodiversity will suffer. The Palmer Z-index talks about drought, and the picture on the right is talking about sea level rise. Higher air temperatures do increase droughts in some places and rainfall in other places. And you can see that with the sea level rise, we will have permanent flooding, more frequent and stronger hurricanes that will cause temporary flooding and significant structural damage. But droughts in the Piedmont and Blue Ridge agricultural areas will negatively impact crops. And so all of these have social and economic implications. Infrastructure and transportation will be affected by climate change, impacting the ability of various industries such as the military, manufacturing, and agriculture to operate. In addition, it may be hard to attract workers to Virginia if the environment is unhealthy. Rising sea levels will make hurricane storm surges worse and force decisions about which waterfront properties to protect and which ones to abandon, and storms will become more extreme. Flood damage costs money and impacts lives. Agriculture disruption costs money and impacts lives. Health impacts such as exacerbated asthma, allergies, heart attacks, heat stroke, all of these things impact lives and cause money. The migration of people and wildlife impacts lives and costs money. And recent studies have even found that violence increases as temperature increases. So what can the community do? It's tricky to be a good public servant. Even if you don't give the people what they want, You might not be in